Okay, everyone, welcome back to week 6 for SAT Math. Just to jump straight into it, we have subtopic 1, area and volume. And our first topic here is area and perimeter of 2D figures. So, to be honest, this topic shouldn't be that hard for most of you, especially those who have taken geometry. For those who haven't, this could be pretty challenging. But we have this question here that says an old square parking lot had a side length of X meters. And keep in mind what they say. They said square parking lot. That makes working with this area a lot easier for us. And it says a company is designing a new square parking lot whose perimeter should be 144 meters greater. Which equation should the company use to calculate the area of the new parking lot? Okay, so we have this old square parking lot with X meters. The new one should be 144 meters greater. So we have to look for X, which is one side. Because this is a square, we can just make the formula 4X, 4 times the side length, plus 144. And we can divide it by 4 just to find out, X by itself, just that one side length. And we can just factor out that 4 and make it easier to work with. And we end up with the length being X plus 36. Now, area for a square is just L squared, meaning that is the correct answer for our formula. Okay, for our second topic, we have surface area and volume of 3D figures. Now, this might be a lot more challenging to conceptualize in your head. If you can't, I recommend drawing. I think that would help a lot of you guys out. If you have trouble drawing the 3D drawings, you can do a net drawing as well. I think especially for surface area, that helps a lot. But for this problem, we're just working with volume. And you don't worry about memorizing all the formulas for volume. They will give it to you on the SAT. So we have here a volume of a square pyramid, base length of 7 meters, and a height of 12 meters. And then there's also a piece cut off the top that is 2 meters tall and has a base length of 3 meters. What is the volume of the resulting figure? Okay, so we're cutting off that piece, so we have to keep that in mind. But the formula for volume is 1/3 times height times base, not the base length, meaning we have the square pyramid, we have to find the actual base, which is just the area of that square. In this case, height is 12 given, and the base is 7 times 7, because, again, a square, the area of the square is 7 times 7, so you just plug it into the formula, and we get 196. You will also have a calculator on the SAT, so you won't have to worry about solving it by hand. And then we also have to find the volume for that piece off the top, which is 2 meters tall and has a base length of 3 meters. So I just simplified it. 3 times 3 times 2 times 1/3 gives you 6. 196 minus 6 equals 190. Okay, second subtopic, we have lines, angles, and triangles. This is where it gets more difficult. We have triangle congruence and similarity. So we have this conceptual question where they don't give us a model, but instead, you don't need one, but if you would like to draw one and it helps you, I would recommend doing so. Ethan wants to know the height of the local library. To figure it out, he places a mirror 150 feet from the base of the library and backs up until he sees the top in the mirror. So he discovers he's standing 10 feet from the mirror. If his eyes are 4 feet above the ground, what is the library's height in feet? Okay. So we have to measure Ethan's distance from the mirror and the height of his eyes over the library's distance from the mirror and the height of the library itself. Now, they give us 3 of these, and we have to find h. So again, just cross multiply, and you search for h, and you get 60. So if it's hard for you to visualize this word problem, just draw it. I think it might help a lot. So you start, if you were to draw it, you would draw like maybe a stick figure, and you would start the triangle actually at Ethan's eye level, not his feet, because that's where he's looking from, which is why you have that 4 feet on top for the height of Ethan's eyes. Okay, for this next one, we have proofs, theorems, and scale factors. So you guys should know your interior and exterior angle theorems. If you have not taken geometry yet, this would be something to maybe learn, maybe Google really quick, but it's just about congruent angles. I won't go over all of them here, but I will explain 2 of them. So we have A and B, those lines are parallel, and the measure of angle K is 4 times the measure of angle H. Okay, so one thing to note is that K plus H equals 180 degrees, but K also equals 4 plus H. So when you, just plug in K, we have 5H equals 180, divide by 5, H equals 36, but we need the measure of M. And if you don't know your interior angle theorems, you kind of have no idea what to do next, but just know that opposite interior angles, which means where H and M are congruent, meaning that is the exact same angle measure, meaning H and M have the same angle measure, so the measure of angle M is 36 degrees. Okay, final subtopic today, we have right triangles and trigonometry. So we have the Pythagorean theorem. So Pythagorean theorem just means when you have a triangle with a right angle, a squared plus b squared, the 2 lengths that are not the hypotenuse, equals c squared, the length of the hypotenuse. So we have this question here. We have a square with an area of 49 feet, surrounded by a wooden frame of 4 triangles. The shorter side of the triangle is 8 feet. What is the area of the entire structure, including the well and the frame? Okay, so if the shorter side of the triangle is 8 feet, we know the measure of the square is 7, because the area of the square is 49 feet squared, so the length would be 7. You can add 8 plus 7 to find the length of the longer side. Then you just use Pythagorean theorem, and we can end up finding the length of the hypotenuse, which is the outside part of the bigger square. And we have that hypotenuse length being 17. And again, because this is a square we're working with, 17 times 17 equals 289, which is the area of our structure here. Okay, last one, right triangle trigonometry and special right triangles. This question is fairly difficult, but special triangle questions aren't super common on the SAT, and if you do see it, it will very, very likely just be 1 question. So this is something to prepare on, but it should not be an absolute priority. However, this is something that is obviously good to know. Also, keeping in account for your geometry classes as well. So we have this isosceles right triangle with a perimeter of 6 plus 6 root 2 meters. We can just draw that out here. And because the isosceles triangle is a 90, 45, 45 triangle, which is a special one, you can kind of just use this formula here, which the isosceles angles, the congruent ones, are x, and the hypotenuse is x times root 2. Okay, so when you have that, you can kind of just add up the the perimeter to equal the perimeter given, meaning you can add up x plus x root 2 equals 6 plus 6 root 2. We have x, we can just factor out x on the left side and then just divide it out. However, we don't have a very clean number to work with, so you can do this FOIL, and it might seem really confusing at first, but if you look on the denominator, we just want to get rid of that root 2. So by being able to FOIL this out, we can eliminate that root 2 on the bottom, because that minus root 2 plus 2 root 2 will cancel out, and that root 4 is just 2. So that helps us get rid of that root on the bottom, which gives us an easier number to work with. And again, you will have a calculator, so you can plug it in and find that the answer is 4 rounded to the nearest whole number. If you have any questions on how to solve this, please leave a comment or let me know during class. And if you like the video, please like and subscribe.